Now, if this object moving with a constant angular acceleration, so what does this mean by this case? This is what you did learn in the circular motion already, but rather than you look after at the picture of the path of motion, like the motion of the object along the path, now you consider the angular displacement instead. And you can also, from the angular displacement like this, you can also my fault, sorry. Since you know the angular displacement, you can also find the omega and the alpha later, which is related to the time that evolved through the event. So if you have seen these kind of things, and also you know about SVAT, what do you think about? The answer is yes. That is the main or major kinematics equations. You did know about the linear kinematics equation. This is from one dimension, and you can also apply this in 2 dimension and 3 dimensions, right? You can move this idea to the angular kinematics equation, or the rotational, if you would like to say it with the rotation word rather than the angular, so that it have the same representation rather than you have the x, if this case moving along x-axis, and you know like x minus x0 is the displacement, right? You rather than you have x0, v0 a t. Now you have the theta zeros, omega zeros, and alpha t instead. X is the terminal position. You can have x or xf, it depends, right? x0 is initial position, v is terminal velocities, v0 initial velocities, a is accelerations, and t is the time. So now you consider at constant acceleration. For the rotation, you have a constant alpha, but for the linear, you have constant acceleration. So this is the case that you're looking after, and you can apply the 4 major kinematics equation to solve the problem. So now you, rather than you have the terminal position, you have the terminal angular position here. This is the initial angular position. This is the terminal angular speed, or you can put as a velocity because you know the direction if you know how to use your right hand rules, right? And omega zeros is the initial angular speed, alpha is the angular acceleration, and t is the times. So it's exactly similar, and the way to derive, you just derive from the linear relation, and just now you substitute omega f in this case instead of v, and you substitute omega I into v zeros. So what I'm writing, that I use omega or omega f, which is repressible, it depends, and a theta, I interchange between theta and theta f if you want. So now all these relation, you can have another set of the angular kinematics equations. We will try to use this knowledge to solve and determine any further predictions or explanation about the behavior of the particle that rotate or change in terms of angular motion. For this problem, a wheel rotates with a constant angular accelerations. Since you've seen something like this Now you can think about the four major kinematics equations, which is in this case, our kinematics equation is in angular. So our four major angular kinematic equations. So what you have, the first one, rather than you have v equal to v zeros plus at, you have omega equal to omega plus alpha t instead. How about the second one? S equal to v plus u, or v plus v zeros over 2 multiplied with t. So you have a theta equal to omega plus omega zeros over 2 and multiply with t. This is the first one. Second one, how about the third one? So if you see, if the angle, you have the information of the omega here, you have the initial time, ti, angular displacement will take until 2 seconds. This is tf. So the delta t, now you have 2 seconds. So you have all this information, and you know the acceleration that initially stayed about 3.5 radian per second square. This is the square, right? So you know information of omega, alpha, and t. If you would like to determine the angular displacements here, how can you have it? It's related to the third equations. So rather than you use the zeta s equal to v0t plus 1 over 2 at square, you can use theta, which is this theta is the displacement, right? So it's supposed to be the angular displacement equal to omega t, which is the initial omega, because it comes from v0t plus 1 over 2 alpha t square. Now you can determine the displacement. This is the angular displacement. Right. So now you can sub all the information in if you want. So I'll clear the space for the fill in. So now you will have the omega zeros is 2 radian per second. This is the initial because it's at zeros time point. So 2 radians per second multiplied with the delta t, the time the change, which is 2, and multiply plus with 1 over 2 alpha, in this case is 3.5, and t squared, which is 4. So finally you can do a calculation, and if you take this in this u as the radius per second and this one as radius per second square, the displacement you should have in the unit of radius. So you have the radius equal to 11 radius. How about if you would like to convert this radian to degrees? So now you have the theta in radians, and you would like to convert to degrees. Since you know that 2 pi radians equal to 360 degrees, right? So that 1 radians is 360 over 2 pi, or 180 over pi in degrees, is in radians. So that means you can multiply it with 180 over pi. So now I will clear this space again. So you have 11 in radians and multiply with 180 and divide by pi. So finally you will have the angle is around 330 degrees. This is the unit. Whether you can answer in degrees or radius is okay. Make sure you have the right unit, because different unit have different value of the angular displacement. How about if you would like to count how many rev? Rev is the way that the object rotate and revolve one round around. We represent it as a rev. So that means if the object rotate back to the same position, this is the reference position, one round is equal to one rev. That means if the displacement of theta equal to 2 pi in radius, it means it is 1 rev. Or if the displacement is equal to 360 degrees, it's also a rev. So now you have the angular displacement equal to 630. Sorry. So if you'd like to determine how many rev, you just have this number and divide by 360. So after you do a some divide from this value, you will find out the solution for the revolution here is around 1.75 rev. So rev represents the revolution here. That how many rounds that this object evolved due to this constant angular acceleration motion of the wheel. So for the third one, what is the angular speed of the wheel at t equal to 2 seconds? So this is a kind like you maybe rather determine the angular speed at t equal to 2 seconds. Thinking about another all that involved into this part. So because this is what happened through the 2 seconds of rotation. We did state about the first equation, the second equation, the third one, and how about the fourth one? So the fourth equation is if you know the relation between the terminal velocity and initial velocity, you have also linked to the acceleration that bind these together, and this is the displacement. If you write down the angular displacement, it is similar to v square equal to v0 square plus 2as. We already know all these informations. We would like to determine the angular speed. So you can find this one by sub all information in. Not only equation 4 that you can use for solving this problem, you can use the first equation as well, as omega equal to omega 0 plus alpha t. Because you already know omega 0s, you already know alpha, and you already know the t. But since I already stated about the first equation, I will sub the third equation to show you, or maybe just sub the first one for the quickest and the easiest way to sub the value. Because if you sub with this equation, you have to substitute all in and you square it up and under square root. So you have to do a lot more in terms of calculation. So I pick up the first equation. So I choose omega equal to omega 0s plus alpha t. And in this case, the omega 0s is equal to 2 radians per second plus alpha, which is 3.5 radian per second square, and the t is 2 seconds. So finally, I can determine the angular speed at t equal to 2 seconds. All right, like this, t equal to 2 seconds. As the final value, which is the 9.00 radian per second. Make sure you have the right unit. So you rather have the radian per second or per second, it will be fine.